Hello everyone, in this video we're going to cover a series test that you need to know to be successful on the AP Calculus PC exam. Here's the table of the 8 series tests that will be tested on the AP Calculus PC exam. The first one is the nth-Term test. Another name of the nth-Term test is Divergence test. The formula is going to be series A sub n. This test cannot be applied to determine convergence. Alright. Now the series A sub n diverges when limit of A sub n when n approaches infinity not equal to 0 or does not exist. Note that if the series A sub n converges, then the limit A sub n when n approaches infinity equals 0. If the limit of A sub n when n approaches infinity equals 0, the nth-Term test is inconclusive, right? So which means we don't have the converse of this guy. Now, the next one is the geometric series. You have two different ways to write the geometric series right here. Remember, if k starts from 1, and then this guy must be k minus 1. If k starts from 0, this guy must be k. So you need to be aware of this guy. Alright, the series converges to s sub infinity equals the first term over 1 minus r if absolute value of r less than 1. Alright, this guy is the same thing as this guy, so keep that in mind. Now, the series diverges if absolute value of r greater than or equal to 1. So this guy is the same thing as this guy, right? Which is you learn from algebra 2. Now, P series is going to be given by this formula. Now, this series converges if the power right here greater than 1. Diverges if P greater than 0 less than or equal to 1. Note that if B equals 1, this is called harmonic series, and harmonic series is the special case of the P series. Alright, and the harmonic series always diverges, so keep that in mind. Now, next one, we're going to talk about the integral test. The formula is given by this guy, and we're going to let A sub n equals f of s. Alright. The series converges if the integral from 1 to infinity of f(s) ds converges. The series diverges if the integral from 1 to infinity of f(s) ds diverges. Remember that the function f(s) must be positive, continuous, and decreasing on this interval. Now, next one, the ratio test. The formula is given by this guy. The series converges if limit of absolute value of a sub n plus 1 over a sub n when n approaches infinity less than 1, and diverges if this guy greater than 1. Now, if limit of this guy when n approaches infinity equals 1, then the ratio test fails, right? Now, next one, direct comparison test. The formula is given by this guy. Suppose we have the series that bigger than this series, right? So keep it right here. Alright. So if the bigger converges, the smaller converges, right? So if B sub n converges, A sub n converges. Now, to determine if the series diverges, we're going to compare this guy with the other one. That is smaller than A sub n, right? So if the smaller diverges, the bigger diverges. So if this one diverges, this guy diverges, right? Now, we're going to move on to limit comparison test. The formula is given by this one, right? Now, suppose you have two positive series, A sub n and B sub n. If the limit of A sub n over B sub n when n approaches infinity equals a number greater than 0, Now, the series right here converges if the bottom converges. The series right here diverges if the bottom diverges. Alright, so keep that in mind. If the number L right here equals 0 and the series on the bottom converges, so is the top converges. If number L equals infinity, then the bottom diverges, so is the top. Now, number 3, both series must have positive terms. Now, next one, alternating series test. So, here's three different formulas of the alternating series you're gonna see on the AP exam. It could be power of n, it could be n minus 1, it could be n plus 1. Now, if limit of a sub n right here equals 0 when n approaches infinity, and the sequence a sub n right here is decreasing, it means a sub n greater than or equal to a sub n plus 1. Then the series converges. Now, this test cannot be applied to determine the divergence. Now, note that to verify if the sequence is decreasing, you need to show that a sub n plus 1 minus a sub n less than or equal to 0. Or you can use this one right here, a sub n plus 1 over a sub n less than or equal to 1. Or f prime of n less than or equal to 0. So, this guy right here and this guy right here are most popular ways to do it. Now, the last one we're going to talk about is the absolute and conditional convergence. We have three possible behaviors of the series a sub n. When analyzing the convergence or divergence of a series a sub n, there are three possible cases. The first one, the series converges absolutely. So if the series absolute value of a sub n converges, then the series a sub n also converges. Second, converges conditionally. If the series absolute value of a sub n diverges, but the series a sub n converges, then the series a sub n is there to converge conditionally. Number 3, diverges. If both absolute value of a sub n and a sub n diverge, then a sub n diverges. Now, suppose you given the infinite series a sub n, right? So what you need to do is to find the limit of a sub n when n approaches infinity, right? You have two possible cases. Now, you're going to check to see if this limit equals 0 or not, right? If the limit of this series not equal to 0, right? So you have this case right here. Then the series divergent by the nth-Term test or divergent test right here. Right? Now, if the limit of a sub n when n approaches infinity equals 0, so it's going to be yes. You're going to check to see if the series is geometric. Now, if the series is geometric, then you're going to check the absolute value of common ratio to see if it's less than 1, right? If it's yes, and then the series converges, right? If it's no, and then the series diverges, right? If this series is not geometric, then you're going to check to see if there are positive terms. If no, and then you're going to check to see if the sign alternates. If yes, and then you're going to check to see if the series decreasing. If the series is decreasing, then the series converges. If the series not decreasing, and then you're going to try absolute convergence. Now after you check the sign and you don't see the sign alternating, and then you're going to try absolute convergence. If there are positive terms, we're going to think about the P series first, right? Now you're going to check to see if this series is a P series. If it is, and then check to see if P greater than 1. If yes, and then the series converges, right? If no, and then the series diverges, right? Now, what if the series right here is not a P series? Think about the integral test. Now, if this one is, the series converges. If you cannot use the integral test, think about the ratio test. If you succeed, and then the series converges. If you cannot use the ratio test, think about the root test. If you succeed, and then the series converges. If not, think about the direct comparison test. If you succeed, and then the series converges. If not, think about the limit comparison test. If you succeed, and then the series converges. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.